One of my subscribers sent this problem to me, and this problem is coming from equation of three moment. Although I have not treated equation of three moment in this group, but I was touched to help him with the solution. So the formula goes this way: mn minus 1 ln plus 2mn into ln plus ln plus 1 close bracket plus mn plus 1 ln plus 1 is equal to minus 6 an all over ln, then plus 6 an plus 1 bn plus 1 all over ln plus 1, close the bracket. You are going to apply superposition principle. In that, you break this beam into two. Since you have just two span, you are going to break it into two. And when you break it into two, in the first span, you have something like this. This is our support. This is another support. Here we have 4 meter, and this is 20 kilonewton per meter. And here is our A. Let's label here A. This place B, and this one C. If we want to draw the bending moment diagram of this particular beam, it's going to be drawn like this. This is a bending moment diagram, and the height of this bending moment diagram can be gotten with WL squared over 8. So that is what our AN talks about, and our AN plus 1 as well. So the height will now be, our W is 20. We have 20 multiplied by L, which is 4. Then you square it all over 8. That will melt down to 40. So you go ahead to get your area. Your area is AN. And area of this particular bending moment is 2 over 3 BH. Our B is what? Our B is the base, and the base is 4, and our height is 40. So the area will end up at 320 all over 3. So from the formula, we have 6an. This is 6an before you have small letter an all over ln. So that's 6an all over ln will be equal to 6 multiplied by our an is 320 all over 3. Then multiplied by an is the centroid of this particular bending moment diagram. And centroid for UDL is L over 2. So the span is the L, and that is 4 meter. Therefore, the centroid, which is an, will be L over 2, which is 4 over 2, and that will give us 2. So we have 2. And the formula says all over LL, which is 4. So everything will be divided by 4. So this will melt down to 320. Now, there are easy way of doing this. If you don't want to start drawing all this bending moment diagram, start using AN or this formula, you can rather go this way. It has 6an all over ln. You can rather use this formula, WL raised to power 3 all over 4, sorry. And that is, our W is 20 multiplied by L, which is 4, raised to power 3 all over 4. When you press it in your calculator, you still have 320. So instead of you going all around doing all this, you can decide to use this formula. And this formula works only for UDL. In our next video, we shall be using the formula for the point load and possibly formula for uniformly varying load. So if you really want to get along with the formulas, you can consider subscribing to the YouTube channel. So having established this formula, can we now talk about this other span without using the bending moment diagram? And remember, in this formula, like the formula has been stated, we are going to go joint by joint. And how many joints do we have here? This is the only joint we have in this particular problem. Had it been, we still have another span here. This would have been a joint. Remember, this is not a joint because you have only one span connecting to this point. So this is where you have two spans connecting at a particular point. Therefore, this is a joint. And at this joint B, whatever that is happening to the left-hand side, you call it Ln or Bn. But whenever you have plus 1, it means it's happening after the joint where you are standing. So for this formula, when we have Mn minus 1, that is moment at point A. And Mn is moment at where you are standing, which is Mb. And for Ln is the span before you, which is 4 meters, when standing at point B. And the span after where you are standing is the Ln plus 1. So, using the formula to get what 6An and Bn plus 1 will be, remember, this An plus 1 is same thing as what we have done here, just that we are adding plus 1 to indicate that considering this joint, whatever that is happening is after where we are standing. That is why we have An plus 1. And this Bn plus 1 is the centroid also to the right hand, from the right hand side. Therefore, in using our formula, which we have established, we have WL raised to the power 3 over 4 to be equal to, remember that side is 6An, An plus 1 rather, and we have Bn plus 1 all over Ln plus 1. So, applying the formula, which is WL raised to the power 3 over 4, will now give us our W here is 15 kilonewton. Our span is 5 meters. So we have W, which is 15, multiplied by span, which is 5 raised to the power 3, then all over 4. So when you deal with that, you have 468.75. So having gotten our 6An plus 1, Bn plus 1 all over Ln plus 1, let's go ahead to substitute into the formula. So we have Mn minus 1, which is moment at point A. So that is moment at A. Then our Ln, the span before the joint where we're standing, which is at joint B. So we have 4. Then plus 2 multiplied by Mn, which is where we're standing, and that is moment at B, into Ln, which is 4, plus Ln plus 1, and that is 5. You close the bracket, plus Mn plus 1, a moment after where we are standing. So this is the support where we are, and moment after the support is the moment at support C, which is MC. Then multiply by Ln plus 1, which is 5. So you can add the 5 here. That is 5 MC. Is equal to, we have minus. Remember, in the first one, we got 320. So we have 320 plus the second span, we have 468.75. So in the second span, we have 468.75. Close the bracket. Now, this is simply supported, and since it is simply supported, there will be no moment at point A and point C. That is, there's no moment for simply supported unless the support is appearing in the middle. But for all these ones that are outside, the moments at A and C are equal to 0. Therefore, our MA is 0 and our MC is 0. You are left with 4 plus 5, which is 9. 9 multiplied by 2 is 18 MB, which is equal to minus 320 plus 46875. Maybe you can check that out in your calculator, and you have 788.75. Our MB is equal to minus 788.75 all over 18, which is equal to minus 43.82 kilonewton meter. So this is the moment at point B. That is the only place where you have moment. And the problem also said that you should get reaction at any of the supports. So considering the first span, you have something like this. Remember, Since this moment is negative, it means that the arrow will be pointing downwards, something like this, instead of upward. So that is the interpretation. This is our point A, and the direction here you can call it VA. This moment here is 43.82 kilonewton meter, and the span is what? 4 meter. The magnitude of the UDL is 20 kilonewton per meter. Therefore, if you want to get any of the support reaction as the question demands, it means that you're going to get at least VA, or if you want to get VB prime, you can get VB prime. So let's take moment at B prime to be equal to what? 0. So you can say let clockwise forces be equal to anti-clockwise forces. If I take a moment here, this VA will move in a clockwise direction. So, and it will cover a distance of what? 4 meter. 4 meter multiplied by VA is 4 VA. Then this moment is also turning in a clockwise direction, so we plus it. We have 43.82 is equal to the one that will move in anti-clockwise direction, and this UDL will move in anti-clockwise direction, and that is what? 20 multiplied by 4 squared over 2. Remember why it is 4 squared over 2? First of all, you multiply with the span, and the UDL will always act at the center. That is why you have 4 over 2. And 4 over 2 is the same thing as what? 2. That is half the span. You can just play around with this and have that VA. Remember, this one cross sign of equality. And you have that VA is equal to 116.18. This is 0.18 all over 4. And that will melt down to 29.045 kilonewton. This is all about this problem. If you have any question, you can drop it in the comment section, or if you think there's any other area you want me to attend to concerning this equation of 3 moments, or you have any problem at all, just react to this video, and I will see how important it is to you. Thank you, and see you in my next video.